Alright, let us now take a look at a second discrete probability distribution, and that's the binomial distribution. So here we can take this one off. Before we go into this binomial distribution, we're gonna have I would say a mathematical intermezzo that will help us later on. The two things I want to discuss is independence of events, as well as how do we count. We're going to have a session of counting. Now, independence of events, we've seen this when we were deriving the base rule. We've seen that the probability of A, B here, A and B happening, is the probability of A times the probability of B minus A. But if A and B are not connected, then the probability that B happens given A is the same thing as the probability that B happens. So if these are not connected, whatever happens to A has no influence on B. So for independent events, the probability of AB equals probability of A times the probability of B. This is when the events are independent of each other. It's also a rule we will use frequently. So now we're gonna learn to count after so many years, and basically what we're gonna do is assess how many license plates we can make if I give you 3 letters and 4 digits. And we're gonna do it in 2 separate cases. In one case with replacement, and the other no replacement. So how many letters can I take? Let's go to the replacement first. So there's 26 letters. I choose one. So this is 26 options, but I now put the letter back. So I again have 26 options. I put again back. So this does not change. And digit, I have 10 options, 0 to 9. So actually not so difficult in this case. What if we do not replace? Well, first of all, we still have 26 in the beginning. But now I already took one. So there's only 25 letters left. So that's going to be 25, and that's going to be 24. This stays 10, and I go to 9, 8, 7. Okay? So what we're going to try to calculate or derive right now is I have a bucket of n elements, and I'm going to choose k of these elements and order them in a list. Okay? And the way we're going to derive that formula is by, having 2 ways of doing it and then make them equal to each other. So this will help us a little bit. So I have n people in this box, and I want to set up a committee of k people. So I go to these n elements and I choose my first person. That means that I have here n options. Okay? Since I already chose the person, I cannot choose it again. So this is no replacement. The second time, I have n minus 1. Third time, n minus 2. Until the end, n minus k plus 1. Why is it n minus k plus 1? Well, let's do an example. Let's have our 26 letters, and we're gonna choose 5. So first we have 26, 25, 24, 23, 22. See, 26, I have to subtract 4 and not 5. Yeah? So this 22 is n minus k plus 1. Okay? That's how I get to this. So this is my first way. I'm gonna do it. So if we look at it, n times n minus 1 and n minus k plus 1, this is the same as n faculty divided by n minus k faculty. Factorial, no? Factorial, not faculty. Okay? Because you can see that a lot of numbers will disappear in this case. The way we're going to prove it is calculate it. So on top we have n times n minus 1, n minus 2, all the way down to n minus k plus 1, n minus k, all the way to 1. Okay? And in the bottom we have n minus k, n minus k minus 1, all the way to 1. Okay? So you can see that all terms from here disappear with that one. Yeah? And this gives us exactly this. See, what is left here is exactly what's here. Okay? So, how we can do this? Well, there's n factorial divided by n minus k factorial. Okay? Now there's another way of doing this. We could first choose k people out of the n. So I can choose all the members of my committee first, and then I'm gonna check how many ordered lists are possible. Yeah? So this reads n choose k. Yeah? How many ordered lists are possible? Well, imagine that we have k equals to 3. Yeah? Then we have a list 1, 2, 3. And of course I can swap the 3 and the 2. Right? Then I could put the 2 in front. 2, 1, 3, 2, 3, 1. That's another one. And then I have 3, 1, 2, 3, 2, 1. Okay? So I have 6 ordered lists that I can make when k is 3. But 6 is exactly 3 faculty. 3 factorial. It's 3 times 2 times 1 equals 6. Okay? So this here is going to be k factorial. So my formula now is that n choose k times k factorial, right? N choose k times k factorial equals n factorial divided by n minus k factorial. Yeah? So that means that n choose k equals n factorial divided by k factorial minus n times n minus k factorial. Yeah? And these n choose k we call the binomial coefficients. Yeah? These are the binomial coefficients. Okay?